Okay, how's it going? So now that we've spent some time with reviewing graphing lines, we're going to move into our next topic, which is called a system of equations. And systems of equations, what you need to know is it literally is just two or more graphs in the same coordinate plane. So over to the right here, okay, I've got this coordinate plane, all right? It's the graph of it's the coordinate plane of an x-axis and a y-axis, all right? And all of these points in here are made up of a pair called x and y, okay? They're just called your points. So what we're going to do here, okay, to be a system is we're going to put two lines on the same graph. So we will draw one line like such, all right, and we'll draw another line, and it could be both of them have positive slopes. They could both have negative slopes. One could be a positive, one could be negative. So there's a whole bunch of different types of lines. But what I want to point out to you is that what we're going to be looking for and observing for is what is called a solution of a system. So over here I have in some notes here that the first thing you want to be writing down here is that systems of equations are two or more graphs in the same coordinate plane. So that means if I give you two equations, I don't want you to make two separate coordinate planes. I want you to graph two lines all on the same coordinate plane. All right, and then what we're going to be looking for is what is called the solution of a system. And the solution of a system is a single point. So all points in a coordinate plane are written as x comma y, which means you have some x value and some y value. And it's the single point at which the lines cross on a coordinate plane. So if I was looking at this example over here, okay, what I would be looking for and trying to highlight, all right, would be where these two things cross. So that would be what I would say is my solution to my system. And then I would define it with, okay, its value. Now, for this one, all right, this one's a really hard one actually compared to what you guys are going to do, because that point doesn't fall at a nice place. Okay, a nice place would be something that would be considered where your two grid lines meet. Okay, so this one here is just using it for demonstration purposes, but I just want to label on this graph that this is the point of intersection. All right. And it has a pair, and it would be listed as x comma y. So that's just something important you want to have. It's just definitions you want to know, because through this video, I'm going to be talking about what is the solution to the system. All right. Now, the solution to a system is often referred to as the point of intersection. Okay, so someone may just ask you, hey, in your system when you're solving it, they may just say, hey, what's your point of intersection? So that they're asking you the same question as what's the solution? And what you need to take out of that is people can ask you for the same thing two different ways. And that is, they can say, hey, what is the solution to your system? And again, that's just where the two lines cross, where they meet. All right, and you list it as a coordinate pair of x comma y, two lines cross at one single point. Or someone could also say to you, hey, what's the point of intersection? And then that is more of a specific way of asking the question, okay? So let's dive in and let's do some practice problems. I've got 3 of them set up here for you that we're going to go through, and what I'm going to do is I'm going to graph them, and I'm going to specifically point out the things to you that you need to be looking for. So here we go. All right, so we're going to go through an example problem here, and it says graph the system of equations. Now, generally 9 times out of 10, when you're going to see directions for these, they're going to say graph the system of equations, and that's it. All right. So this part that I'm going to go ahead and highlight in blue here, this and determine its point of intersection, is not something that is going to be commonly written, okay, on a directions for solving systems of equations. So the part in blue is just something you have to get in the habit of naturally doing. So if you see the word graph a system of equations and This is the part where it says and determine its point of intersection is just something you have to learn to automatically do, whether someone asks you to or not. It is what we say to be an implied direction for you to do. So let's go through an example problem here. And the example problem we're going to go through here is a system. Now, a system is defined as two or more equations. I will tell you right now that every graph that you are going to do in this class will just be of two lines. So my system here is two lines, so I'm going to coin them, right, just for this video so you know what I'm talking about here. I'm going to call the first one, I'm going to call this like line A, and I'll call the second one like line B. All right. And the reason I'm separating them again is because I just want to review going through and looking for the slope and the y-intercept of a line. So what we need to remember here is that, okay, the number that is not with the x, it's not paired with the x, all right, it's not grouped with the x, whichever way you want to think about it, is what we call to be the y-intercept. So on a line, all lines have to start from one individual point to be connected to another one. So this value for A, okay, the y-intercept, the point of beginning, its starting point is going to be on the y-axis at the value of -4. And then we take a look at the number that's paired with x, okay? So the number that is paired with x is what is called to be the slope, which is m. Now, in this case, it's 2, but the problem is when graphing, all right, graphing a line has to have a slope written as what we call a ratio, which is also the words for a fraction. So whole numbers can be simply written as fractions pretty simply by taking them and writing them over 1. So now, all right, doing this problem one at a time, okay, I'm going to graph the line A, all right, and then I will go back and worry about graphing line B. So let's go ahead and graph line A. So one line at a time, take it one step at a time here. So I go locate the point -4 on the y-axis. So remember, you have to be very, very careful because a lot of people like to start over here because this is a -4 as well. But the problem is that the value is defined as the number on the y-axis. So the vertical axis is called the y-axis. All right, so we're going to go ahead and plot that point at -4. So here we go, plotting that point. And then from there, I go ahead and use my slope. And the slope is the change of y divided by the change in x. So because this is a +2, that means we're going to go up 2. We're going to go up 2. All right. And then the bottom number, because it's positive, means we're going to go right 1. So I go up 2, then right 1, and after I do both of those directions, I will plot a point where I end up. So following that pattern, I go up 1, up 2, and over 1, and plot that point. Now, okay, what some kids make a mistake here is that they don't continue this pattern. And remember, the reason I really want to continue the pattern more so on this one, I just don't want to draw a line with just 2 points, is because one of these points that I draw, my other line is going to run into. And it doesn't always work out that way, but for our introductory here, I'm letting you know that out of all the other points I'm about to draw, one of these points is going to be the place where my other line also crosses through. So I'll demonstrate that at the end, but let's just continue on from now. Let's continue on with this pattern because slope is constant, which means I can continue to do that same pattern over and over again. So from each point, I go up 2, right 1, up 2, right 1, continuing with that pattern. So I hope you can see me here marking those points as I continue on with that pattern. All right, now we can't forget about the points that are to the left of a line, right, or the left of this y-intercept. So all I have to do is reverse the direction. So if I think about going backwards, all right, from this point trying to get to here, well, how do I get there? I go down 2, left 1. So now I just continue that pattern going on, down 2, left 1. So here we go, down 2, left 1, down 2, left 1, down 2, left 1. All right, so there I have it. There's all of my points. And now what I'll do is I'll go ahead now and I'll draw my line through. Now again, the the niceness of this is that notice when I tried to draw this by hand, right, without a ruler, my line was all squiggly. But I don't have to worry about that, okay, because I'm telling you out of all of these points that I just did here, okay, so I'll highlight them really quick, okay. I'm telling you that one of these points, all right, that I'm highlighting here is going to be crossed through by my next line. So that's the reason why I wanted to do all those points. So let's go find out which one of those points my next line goes through. So here we go, on to B. So B says, So B says here, all right, we're going to be looking for some points. The first thing is the y-intercept. So we're looking for the number that isn't paired with an x, which is y-intercept is going to be the number positive 4. And then we're going to look for m. So we're looking for the slope of this line. And the slope of this line is the number that's paired with x. So that means it's -6. Now we always liked it written as a fraction. So an integer can simply be written over the value of 1. So now let's go ahead and do this problem and then get our point. So now we go to the y-axis. So I'll plot this one in green. So I got the +4, plot my point, and then I follow my slope. Now because this number in front here is negative, the 6 will go down 6, and the bottom number will go, because it's positive, the bottom number will still go right, which is okay. So here we go. Counting from my point, I will count down 1, 2, 3, 4, 5, 6, then right 1. And look at that. I end up directly at a point that I've already plotted. So that's the cool thing about making sure, okay, and I'm going to plot right over that. Now, for this one, because the implied direction is determined where they intersect, so my second line, I don't really worry about that one so much. Okay, I don't really continue all the points. As soon as I get the point where they cross, I go ahead and I just sketch my line in through there, and then I'm done. Except for, okay, remember that you have to determine the point of intersection. So this is the part that can be tricky. So this right here, okay, that point, this point right here, all right, is where they intersect. So that point that I just put a big old star around, okay, I have to label its coordinates. So it comes to you as x comma y. So here's where things can get tricky, because remember when you label points, points are labeled from reference to what is called the origin. So the origin is this point right in the middle of the graph that I'm putting a big pink dot at. So now the tough challenge that you're going to have to face is, we just went through slope, all right, where we were looking at going down over y's, with y's going up and down and then over. So now when you label your points, you just have to be careful that when they match, all right, this point here is going to map to a x value and a y value. So notice I'm drawing them with reference to the axis. So the value of that point is going to be at +1, comma, -2. This right here, out of everything I just did, this is the answer. Okay, that is what we're looking for. You did all of that, I explained and went through all of that work to get that graph just to get to that answer. So make sure that when you're doing these things, all right, this is the end goal. The end goal is to get right here to this. So I'm going to give you a couple problems to try to go through. So it's just going to be graphing lines. So I hope this was enough, and just see how it goes and try the problems out. But remember, what you're looking for is you're looking for where the two things cross.